An introduction to the fuel cells. Fuel cell is a class of devices that convert the chemical energy of a fuel directly into electricity by electrochemical reactions. A fuel cell resembles a battery in many respects, but it can supply electrical energy over a much longer period of time. So let's see how fuel cell is different from a battery. A battery is a closed system, whereas a fuel cell is a continuous system. That means a fuel cell is continuously supplied with fuel and air or oxygen from an external source, whereas battery contains only a limited amount of fuel material and oxidants that are depleted with use. In batteries, various kinds of electrodes are used that are usually solid, whereas for the case of fuel cells, anode is usually a fine powder or platinum powder, whereas the cathode is composed of nickel or different types of nanoparticles. These nanoparticles or nickel are in contact with the gases. So here the electrodes acts as a catalyst. That means inert metals retain their properties and gases are evolved during the reactions over the surface of these electrodes. And the other difference is in the fuel cells, there is no need of charging and discharging cycles, but continuous supply of fuel is needed. And in the case of fuel cells, the corresponding ratios are very simple. For example, for the case of efficiency, the amount of fuel required over the amount of electricity produced are significant. Another significance of using fuel cells for batteries is they generate no or very minute pollution to the environment, whereas the damping of the batteries is a serious issue because most of the batteries are based on the lithium and lead ions. So the fuel cells can be compared with the combustion engine, and where the compressed air or oxygen is used as fuel, and they produce energy and require cooling because the reaction is highly exothermic. Cooling system is required for the fuel cells like radiator. But the basic difference between the combustion engine and fuel cells are the fuel cells generate electricity, whereas the engine produce mechanical energy. So these are the reasons that fuel cells have been used for decades in space probes, satellites, and manned spacecraft. Around the world, thousands of stationary fuel cell systems have been installed in utility power plants, hospitals, schools, hotels, and office buildings for both primary and backup power. So this backup power is many waste treatment plants use fuel cells technology to generate power from the methane gas produced by decomposing the garbage. And now let's discuss the principles of operation of these fuel cells. A fuel cell system is actually a group of cells has a matching pair of electrodes, and in each component of a fuel cell there is an anode which supplies electron to the external circuit, and the cathode which absorbs the electrons. And both the electrodes must be immersed in and separated by an electrolyte, which may be a liquid or a solid, but must be in either case conduct ions between the electrodes in order to complete the chemistry of the system. So a fuel such as hydrogen is supplied to the anode, where it is oxidized, producing hydrogen ions and electrons in an anode direction given here. Whereas an oxidizer such as oxygen, that is the molecular oxygen, is supplied to the cathode, where the hydrogen ions from the anode absorb electrons from the external circuit. So simply we can say that when the oxidizing agent or molecular oxygen is applied to this system, that is bubble to the cathode, where it absorbs the electron from the external circuit, and hydrogen that are moving through this electrolyte membrane, that is also known as selectively permeable membrane for the hydrogen ions. So the protons are coming from the anode and the electrons are coming from the external circuit, making the oxygen molecules to react with these two species and produce water. The difference between the respective energy levels at the electrodes, that is EMF or electromotive force, is the voltage per unit cell. And here the amount of electric current available to the external circuit depends on the chemical activity and amount of the substances supplied as fuel. So here oxygen and hydrogen are supplied to the fuel cell, and for this fuel cell the current producing process is continuous for a long period of time, as long as there is a continuous supply of the reactants, that is hydrogen and oxygen, for the electrodes and electrolyte of a fuel cell. That means these protons must have a continuous supply from the anode towards the cathode. So this system is unlike those in a regular battery, are designed to remain unchanged by the chemical reaction. Practically, a fuel cell is necessarily a complex system. It must have features to boost the activity of fuels, pump and blowers, fuel storage containers, and a variety of sophisticated sensors and controls with which to monitor and adjust the operation of the system. So what are the features of fuel cells? The first one is boost the activity of a fuel. It requires pumps and blowers, fuel storage containers, a variety of sophisticated sensors and controls which are used to monitor and adjust the operation of the system. So overall operating capability. And lifetime of each of these design features may limit the performance of fuel cell. So these operating capability and lifetime of each of these designs limit the performance of the fuel cells. So here comes an important parameter, that is control over temperature of the system. So as in case of other electrochemical systems, fuel cell operation is dependent on temperature, the chemical activity of the fuels and the value of activity promoters or catalysts. So the chemical activity of the fuels, value of the activity promoters and catalyst is reduced at low temperatures, that is as low as 0 degree centigrade or 32 degree Fahrenheit, whereas very high temperatures on the other hand improve the activity factors, means the efficiency of the fuel cell, but may reduce the functioning lifetimes of electrodes, blowers that are used to blow air within the fuel cell system, construction materials, and sensors. So each type of fuel cell thus has an operating temperature design range. So the very high temperatures and very low temperatures are not applicable to optimize the performance of the fuel cells, but a fuel cell has an operating temperature design range, and a significant departure from this range is likely to diminish both the capacity and lifetime. So there is a need to optimize the operating temperature design range in which a fuel cell can have its optimized or maximum performance and utility over the long period of time. And this temperature range must be maintained throughout the course of these fuel cells operations. Other factors which control the optimized operation of the fuel cells include requirement of the continuous flow of fuel for the utilization of the fuel energy. An oxidant must be present. In the absence of an oxidant, fuel cannot be utilized for the conversion of chemical energy of fuel into the electrical energy. So here the fuel that is utilized for the conversion of chemical energy into electrical energy, that is usually in the form of hydrogen and alcohol, etc. So the production of fuel is an important obstacle that insert a separate cost to the overall cost of these fuel cells. So for the optimized operation of the fuel cells, these encircled points are the limitations that must be fulfilled in order to get the fuel cells may convert fuels to useful energy at an efficiency of as high as 60%. that is much better than the 40% efficiencies of the internal combustion engines. So this high efficiency means that much less fuel and smaller storage containers are needed for a fixed energy requirements. So for this reason, fuel cells are an attractive power supply for space missions of limited duration and for other situations where fuel is very expensive and difficult to supply. So this highly efficient fuel cell system require less fuel and smaller storage containers that are needed for fixed energy requirements, and thus they act as attractive power supply systems for space missions that is required for limited duration and may also used as other situations where the fuel is very expensive and difficult to supply. Another attractive feature of these fuel cell is these fuel cell systems emit no noxious gases such as nitrogen dioxide and produce virtually no noise during the operation. Another important significance of using fuel cells as fuel energy converters that a fuel cell can be designed to operate reversibly. In other words, the sum of the anode and cathode directions that are given here gives the direction that is for a hydrogen oxygen cell that produces water as a product. It can be made reversible to regenerate hydrogen and oxygen. Such a regenerative fuel cell entails not only a revision of electrode design but also the introduction of special means of separating the product gases. That means the cell represented here for the conversion of hydrogen and oxygen to water and electrical energy cannot be used for as reversible, but it requires some revision in which water will be provided as a fuel and the oxygen and hydrogen will be generated as the products that must be separated using special techniques. So for the reversible system, special means for the separation of these products must be fulfilled. So this cell system that is represented here is actually for the conversion of hydrogen and oxygen to water and electrical energy. So a fuel cell can be work as a bidirectional operator if we have applied revision of electron designs and the electrode system. So this electrode system in a form of fuel cell can be used as a reversible interconversion of these two kinds of chemical energies. Eventually, power modules comprising this type of high efficiency fuel cell used in conjunction with large arrays of thermal connectors. As the forward direction is the exothermic, whereas the reverse will be the endothermic. For this kind of system, arrays of thermal collectors for solar heating or other solar energy system may be utilized to keep energy cycle costs lower in longer lived equipment. So these kind of fuel cells that are based on the reversible chemical reaction, it requires the input of thermal energy that can be comprising of large arrays of thermal collector for solar heating or other solar energy systems.